These are the mechanical notes. The essential question that you're going to be filling out at the top is, how do mechanical waves transfer energy through matter? So we are going to be going over specifically waves, the different parts of waves, and how they go through different pieces of matter. In the top right-hand corner, there are two vocabulary words we need to know. Energy. Energy is the ability to do work. So if you take a look, we have a battery right there. Brand new battery has lots and lots of energy, so it's able to do work. When you have lots and lots of energy, you have the ability to do a lot of work too. When you have a little energy, you're able to do just a little amount of work. Matter is something that has mass and takes up space. So remember, mass is how much stuff something has, and it takes up space. So matter is what it's made up of and how much space it takes up. So topic question number 1, I want you to make sure on the left-hand side, so stop right now. On the left-hand side, you need to fill out topic question number 1. What is a mechanical wave? So mechanical waves are disturbances, so things that upset the regular nature of things that transmit energy through matter. So here I have some examples of some energy. The one is water waves. So when you go to the beach, you have waves, that is energy coming through the water. Also, when you drop a rock or a marble on something, it has ripples. That's also energy going through the water. Sound is also a vibration that disrupts matter by the energy of the vibration. Seismic waves, so seismic waves, earthquakes, those also have a disturbance of matter. Okay, we need to go to topic question 2. So you should be first on the left-hand side. So make sure you're on that left-hand side. And we're going to go over what is a medium. We are not talking about a medium shirt or medium pizza. We are talking about the matter that a mechanical wave can travel through. That is either a liquid, a solid, or a gas. Sound waves can travel through gas like the air. That is how you hear things. It can also pass through a solid. For example, if somebody is screaming like a banshee in the hallway, we can hear it in the classroom because sound can go through the door and through the walls. Example I gave earlier when we were going over vocabulary, sometimes there will be speakers that are underwater. You can hear sound through there. When I go scuba diving and you need to get somebody's attention, usually I have a metal thing, a metal key that you can tap against the metal tank, and that sound wave goes in all directions pretty quickly, so somebody knows to look around because somebody is trying to get your attention. Still on topic question 2, talking about medium. We use sonar. Sonar is echo, so we send sonar out and it comes back as an echo. We use water and sound waves to do that. Bats use sonar and an echo to communicate and travel also, that is through the air. I was trying to think, whales. Whales also use sonar and echo to communicate and get around. Seismic and sound waves can travel through a solid like the Earth's crust. That's how we get earthquakes. Sound waves travel fastest through solids. So out of everything, solid, liquid, and gas, they travel fastest through the solids because there are way more particles and they are closer together. Still on topic question 2, what is a medium? Would you be able to hear a train coming from farther away by putting your ear on the track or by listening through the air? And why? So I'm going to be asking a question and let's see what you think. Okay, we are now on topic question number 3. So you should be on that left-hand side. So stop what you're doing, be on that left-hand side, and you are going to complete topic question number 3. What are the types of mechanical waves and how do they transfer energy? So transverse waves are waves that go up and down. So usually when you think of waves, you think of transverse waves. The particles of the medium vibrate in a direction perpendicular to the direction that the waves move. So basically, the wave's going left to right, so you see the wave going up and down. We're going to watch a quick video. You may have been at a stadium before and you've done the wave before, so let's take a look at that. So they are going around, and it's like a wave or like a regular wave that we're talking about in science, because people go up and then they sit down, and then they go up and they sit down. So that is very similar to a transverse wave. Still on topic question number 3. We also have longitudinal waves. So if you think of a slinky, when you push it, it goes forward and comes back. So the particles vibrate in the direction that they're also moving. So they go from left to right, and the wave also vibrates left to right. We are going to be sticking with transverse waves for the most part. So on topic question number 4, you need to stop, look at the left, and fill it out. What is the anatomy of a transverse wave? So what we're going to do is we are going to be talking about the different parts of a transverse wave. So first thing, you see this dotted line. This dotted line is right smack in the middle. It's called a midpoint, and it is also can be called the origin. Oops. And I don't know why it doesn't want to type. Let's try this instead. Not very easy with a mouse to write. So you will hear it called midpoint and origin. It's right smack in the middle. Then what you have is at the very, very bottom, right there, is the trough. And like we talked about before, it has that U shape. And that U shape is like the trough that a pig or animal on a farm. The highest point, which is this point right here, is the crest. The crest is the highest point. From the origin or midpoint to the crest is amplitude. The amplitude is how tall a wave is. And then wavelength is going from one crest to the next, and it tells you how long the wave is. Back to pointer. Whoops, and now I need to erase because apparently it stays. Nope. I want a big eraser. Clear off. There we go. Okay. So the wavelength is the distance from one crest to the next. The amplitude is the distance from the midpoint or origin to the crest. The higher the amplitude, the more energy the wave has. And so it's also the smaller the amplitude, the less energy a wave has. Frequency is how many waves we can have during a certain amount of time. So what we do is we will count, let me get the pen, we will count here, we're at the origin, we go up, we have a crest, we have a trough, so we have 1, we go up, we go down, we have 2, we go up, whoops, we go down, we have 3. So we have three waves per second. Let me erase. Let me get back to the pointer. Okay, so now we're going to try. What we're going to do is we're going to figure out the wavelengths, the amplitude, and the frequency, and then we're going to figure out which one has the highest of each of those and which one has the lowest. So first thing, we have wavelength. So wavelength is we are going from crest to crest. So I want you to go ahead and figure out what is the wavelength. So go ahead, draw it on your paper or pick which one in the Kahoot, and then we'll go from there and we'll fix it on your paper. So wavelength, what you're going to do is you are going to start at one crest, go to the next crest, and so this here is the wavelength. That is how long the wave is. Next we have amplitude. See if you can figure out what the amplitude for this wave is. So the amplitude for this wave is, I am going to first draw a line where my midpoint is, or my origin. I'm going to change my color. I am going to start right here. This is my crest. And then I'm going to get a new color. Let's do green. And from the crest to the origin, that is my amplitude. The smaller the amplitude, the less energy it uses. The higher the amplitude, the higher it is, the more energy it uses. Next is frequency. So let's see if you can figure out what the frequency, how many waves I have for the turtle. Okay, to find out frequency, what you're going to do is you're going to start here. I have here, I go to the crest, I go to the trough, I have the midpoint, that is 1. I have a crest, up, that's it. So I just have one wave for this amount of time. Oops. Next we're going to do the rabbit. So we need to do the wavelength for the rabbit. See if you can do that. Wavelength for the rabbit, what I'm going to do is I am going to go from one crest to the next crest, and that tells me how long the wave is. Next, I'm going to do amplitude. See if you can figure out amplitude. Okay, with amplitude, the first thing I'm going to do is I'm going to put in the origin or the midpoint. So right smack in the middle. There we go. So that's not what I do. No. For frequency, what I need to do is I need to see how frequent this is for a certain period of time. I'm going to start here. I have a crest, I have a trough, I have the origin, that's 1. Then I'm going to do my second one, origin, crest, trough, origin, that is 2. Then I'm going to go ahead, origin, crest, trough, back to origin, that is 3. Then I'm going to go ahead and start the origin, crest, trough, that is 4. Then I'm going to go ahead, let's do blue, crest, trough, origin, that is 5. And let's do yellow, origin, crest, up. I don't have enough, so that I have 5. The frequency is 5. Oh, I did mess it up. So for amplitude, what I'm going to do is I am going to draw my origin, my midpoint, whoops. For my amplitude, I'm going to draw my midpoint or my origin, which is going to cut my wave in half. I am going to start right here. I'm going to go to the crest. And so my amplitude, how tall it is that right there. Frequency, see if you can determine how frequent this wave is with the rabbit. Okay, next we're going to do the giraffe's wavelength. See if you can figure out the giraffe's wavelength. Okay, the giraffe's wavelength. Let's go ahead and get the pen up. I'm going to go from one crest to the next crest, and this is the wavelength for the giraffe. Next, see if you can figure out the amplitude. Okay, the amplitude, first thing I'm going to do is I'm going to draw the midpoint, or also known as the origin. I'm going to go ahead and start at the midpoint. I'm going to go up to the crest, and then I'm going to go ahead and draw my amplitude. I'm going to go ahead and figure out my amplitude. I'm going to go ahead and draw my origin or midpoint. Okay, I'm going to go ahead and figure out my amplitude. The first thing I'm going to do is I'm going to draw my origin or midpoint. I'm going to start here. I'm going to go up to the crest, and that there is my amplitude. Next is frequency. How frequent is the wave for the giraffe? Okay, let's go ahead and start. We start with the origin. I have a trough, I have a crest, I have the origin. That was ugly, but that's okay. So that is number 1. Then I have the origin, I have a trough, I have a crest. Go back to the origin. That is going to be 2. Then I go ahead, I have my origin, I have my trough. Whoops, let's get a different color. Here we go. I have my origin, I have my trough, I have my crest, I have my origin. That is 3. And then I have my origin, I have the beginning of a trough, so my correct answer is 3. Okay, wavelength for the mouse. I have one crest, I have the second crest, and this here is my wavelength. Amplitude, what is the amplitude? Okay, first thing I'm going to do is I'm going to draw my origin or midpoint. This is a little bit harder because it's much smaller, so a lot less energy. I have my origin, goes up to the crest, and that is my amplitude. Frequency. What is the frequency of the mouse's wave? So here I'm going to start at the origin. Whoops. So here I'm going to start at the origin. I have a trough, I have a crest, I have the origin, so that is 1. Here I start at the origin, I have the crest, I have the trough, then the crest, and then the origin, that is 2. Start at the origin, have the trough, have the crest, go to the origin, that is 3. Start at the origin, go to the crest, go to the trough, then the crest. Okay, so let's go ahead and do that. We have trough, crest, origin, that is 1. Origin, trough, crest, back to the origin, that is 2. Origin, trough, crest, origin, that is 3. Origin, trough, crest, origin, that is 4. Origin, trough, crest, origin, that is 5. Origin, trough, crest, origin, that is 6. Origin, trough, crest, origin, that is 7. Origin, trough, crest, origin, that is 8. So the frequency is 8. Which one of these has the highest wavelength? So which one is the tallest? So we have already looked at the wavelengths, and if you take a look at your notes, the giraffe has the tallest wavelength. Next is which one has the lowest wavelength? The shortest. Okay, which one, instead of highest wavelength, probably longest wavelength. So which one is the longest from crest to crest? That would be the turtle. This crest to this crest is the longest. Everybody else has their crest closer together. Who has the lowest or shortest wavelength? The shortest or lowest wavelength is the mouse. The two crests are the closest together. Next, which one of these has the highest amplitude? The highest amplitude is the giraffe, because if you take a look from the origin, it is the tallest one. Which one has the lowest or shortest amplitude? That would be the mouse, because when you take a look at when it is from the midpoint to the crest, it is the shortest. Which one has the highest frequency? The highest frequency is the mouse. It has a total of 7, it looks like, 8. Which one has the lowest frequency? Lowest frequency is the turtle.